Hi everyone, welcome back again. So today we'll be discussing something called VLSM. It's difficult for me to pronounce, but let's try to do it again. VLSM. Okay. So what is VLSM? VLSM is variable length subnet mask. Okay. So you might be thinking, what is this and why should we learn VLSM? Okay, that's most important question, the why. So in your why, you need to understand that we have right now IPv4 and we have IPv6 addresses. You will notice that although we have IPv6, we are still running with IPv4. It was said theoretically that IPv4 will be exhausted, but still we are using IPv4 widely. Yes, many of the ISPs, many of the WAN links are right now in IPv6, but still most of the organization, they are running on IPv4. So there are two, elements, or I should say, there are two most important techniques which help survive IPv4 still now. One of them is VLSM, and another one is called NAT. Today's discussion, it's not about NAT, it's about VLSM. VLSM makes sure none of the IP addresses are wasted and it's been used efficiently and it is assigned efficiently all across your network. So let's go deep dive into it. VLSM, variable length subnet mask. So this is the most efficient technique of performing subnetting. I call it subnetting of subnetting. Or once you do a subnet, you do further subnet on it. That's called VLSM. Okay, so you will not understand unless we go through some real example of it. So let's go through a real example. Let's assume, let's assume you are a senior network engineer and you are working for a XYZ company. So in the XYZ company, that's the diagram for you. You have one head office, which is in New York, which is having 58 servers, which means you need 58 public IP addresses. The other three locations are your branch offices. One of them is in San Diego, California, where my friend lives over there. So San Diego, California, we have 29 servers, means 29 IP addresses. And we have a WAN link between San Diego, California and New York. Then we have Kansas, and Kansas is having 12 servers or 12 IP addresses. And we have a WAN link between Kansas and New York. Then we have Texas. Texas is also having 12 servers. That means 12 IP addresses, which we need to connect to the New York using a WAN. So let's see. Let's try to solve it. So the most important thing, solving problems. Before we go through the VLSM, let's try to understand the problems in our personal life, in our day-to-day life. So when you have multiple problems, what is my approach? It is like, if I have multiple problems, I look into the biggest problem. Why? Because if I am able to solve the biggest problem, it's very easy for me to solve the other problems. The other small problems are like, you'll feel them as peanuts. Well, I'm not trying to dictate that this is the way you should solve your problems in your personal life, but that's my approach. For VLSM, this is what we need to follow, that you need to make sure that you follow you start with solving the biggest problem. So in the last diagram, in the diagram, what we have seen, so here, what we have seen that New York is requiring to have 58 servers or 58 IP address. That's the highest number. So if we can solve New York, we can solve others easily. Okay. So let's go through it, how we can solve for New York. So this is the requirement for New York, which is 58 servers. And this is the math over here. For 58 servers or 58 IP addresses, let's say 2 to the power 4, 16. No, it's not going to work. 2 to the power 5, 32. No, it's not going to work as well. 2 to the power 6. Yes, that's the right one. That's the right candidate. So 2 to the power 6 means 6 bits we required into the host portion. Okay. So let's see how it works in the binary. So here, see here, that's the IP address that's been given, which is 192.168.1.0/24. In your real world, or in the in the real world, we will be solving with the public IP addresses. But here, for sake of our example, we should go for RFC 1918 addresses only. Okay, so that's the thing. 192.168.1.0. Let's do a binary on it. So this is the first octet, which is 192, which requires 1. The first 2-bit 128 plus 64, which is 192. Then 168, which is 1010, which is 128 plus 32 plus 8, which is 168. And then the third octet is all first leading, 7 leading zeros, and then 1, which is 1. And the last octet is all zeros. I highly recommend you guys to go through my previous videos, which I have described or which I have explained for, which I have explained how to do the subnetting, how to perform the binary address, how to find the binary address, and how to find the network address, broadcast address. So I would highly recommend you to go through the previous videos, which is available in the description. So, okay. So this is the binary for it. I hope all of you understood. Let's move forward. So as per the map, we have found that 6 bits are required. So we have 4 possible combinations. The combinations are 00, which is over here. You can see 00, 01, 10, and 1. Okay. So if we are considering only subnetting, in that case, we will have 4 subnets, considering 58 servers only. Now let's see the magic. Let's see the beauty of VLSM. So VLSM, we have discussed that it's called variable length subnet mask. So variable length subnet mask means what? That means solving the other networks, you will see a variation of the length of subnet mask. That's it. So again, a little bit of recap. This was for the New York, and we used the first subnet, which is 00. And rest of them was 01, 10, and 11. Got it? Okay, let's see the next. New York, if we are considering New York, in that case, we have network address, broadcast address, first IP, and last IP. Okay, so if you consider finding the formula for network address, keep in mind that all host bits are zeros. So we can see here, if you are considering all host bits are zeros, which is 192.168.1.0/26. Broadcast address, which is all host bits are 1, which is the broadcast address, and that means 192.168.1.63. First IP is after the network address, and the last IP is before the broadcast address, which you can see over here, 192.168.1.1, and the last IP is 192.168.1.62. Got it? Subnet mask is very straightforward, finding the formula. For finding the formula of subnet mask, you need to make sure all the network bits are 1 and all the host bits are zeros. And if you convert them into decimal, this is what it is, which is 255.255.255.192. Okay. So now the magic of VLSM starts. Okay. In our example, if you recall, okay, I should tell you guys, you need to make sure that you note down the diagram. Okay. So for New York, we required to have 58 servers, but in San Diego, California, we required to have 29 servers. That means that there is a difference, and we are not going to use the same 6 bits over here. That's the beauty of VLSM. So we need actually 5 bits to satisfy our requirement. So if we are considering 5 bits, 2 to the power 5, which is 32. So that's how we solve our problem. for San Diego, California. Okay. So now here we have remaining subnets. If you recall, the first subnet was 00, and the other subnets were 01, 10, and 11. We are gonna use 01 for San Diego, California. Okay. So let's see now, San Diego, California, if you are considering 01 and 5 bits into the host, we have one more bit which can be borrowed into the net, which we have done here now. So 01, we can have two more, we can have two combination, which is 010, which is over here. You can see 010 San Diego and 011, which we can use for later. So let's consider 010. Okay, in considering 010, we will be having 27 bits into San Diego, California. That means if we are using network address, this will be our network address, which is 192.168.1.64/27. And in the subnet mask, it's the same formula, but in our subnet mask, it will be 255.255.255.224. So if you recall our previous example, which was used for New York, in that case, it was used for /26, if you recall this. So there is a variation in the subnet mask. That's VLSM, baby. Okay. Now here, for Kansas and Texas, that's the most interesting thing I would say. So for Kansas and Texas, if you recall here, we are considering 011. Okay, so still 01, 010, which is used for San Diego, then 011. So let's see here, considering 011, we have two more combination, which is 0110 and 011. So this is used for Kansas and this is used for Texas. So here for Kansas and Texas, all of them we require 2 to the power 4, which is 16. That means we need only four host bits. Got it? So in the decimal, it's gonna be 255.255.240. For mask, it is /28. That's the beauty of VLSM. Yes. So let's see the map, the whole picture. This is the VLSM picture. So we had 192.168.1.0/24. Yes. And now what we can see for New York, we use 00. That's for New York. Then we found okay, let's try to give you more insight into it. 000110, these are the last octet. And we are considering this one as binary. And these are the subnet bits only. Okay, so focus on this one only. So 00 was New York, 01. Then we found out 010 can be used for San Diego, considering 5. Considering how much bit was 6 bits? Yeah, 5 bits. That's right. So 011, then we got 0110. This is for Kansas, and 0111. That's for Texas. I believe all of you are in line with me. Now, the most important thing, we are done with the subnets. I mean, we are done with the branch offices and head offices. Head office means for the New York. Now, remaining for the links. Keep in mind, in the link, let's go to the diagram again. Okay. So here in the link, let's consider these are the routers. So New York, we have one router. San Diego, California, we have one router. So between the WAN link, for the WAN link, we have two hosts. One of this router and one of another router. It is in New York. Same thing for the WAN link between Kansas to New York. We have two hosts. For between Texas to New York, we have two hosts. That means we need only 2 IP addresses. So if you can solve and you can understand how we have done VLSM for all this location, you should be able to solve for the WAN link as well. Clear? Got it? So now, let's see the last, this is the one. New York, 58 server, subnet mask, CIDR is /26, San Diego, we had /27, Kansas 28, 28. For WAN links, that's the challenge for you guys. You need to solve it. And if you cannot solve it, put them into your comment box. I'll try to help you guys. For now, thank you so much thank you so much being with me. And I hope this session has been very much informative to you guys. Bye-bye.